have implemented a dynamic boss system in which it adapts to how you move and how you interact with the boss, and it learns from it and attacks you accordingly. So what it does, it basically returns. We have made an API endpoint which returns the next boss state the boss should execute to attack you. And we have used a lot of technology like Redis, face, text emitting models, and some LLMs as well. So I'm not going to go too deep in how all the things work. So let just a brief introduction. So what it does is you provide a vocabulary, and the vocabulary basically consists of all the states you have made, all the sound effects you have, all the terrains you have made, and health, xy coordinates, etc., etc. And according to it, our system learns and like gives the boss next state to like attack you with. How this helps is that like now it learns from you, and you know, like, and boss know like this is the next move you're going to execute, and this is how I'm going to counter it. So you basically have to go with different play style to defeat the boss. And now that we have implemented the vocabulary system, it basically works with everything. Any of the game, let it be RPG, MMORPG, turn-based games, and fighting game as well like Tekken and all, cause you can block, dash, everything.
Okay, so Vaibhav briefed you about the technology. Then I'll just brief you about what challenges we faced and what is for the future. So during development, we came to the conclusion that we need to train our own specific AI model, because the latency of any general AI model, we've experimented with 5, experimented with Llama 3.1. Right now we're using OpenAI GPT 4.1 Nano, and we found out that we need a really good AI model with the strong reasoning as well as strong performance, specifically fine tuned for our this reinforcement learning purpose. And we also came to the conclusion that we need good algorithms for searching, because there will be a lot of states generated. Because right now what is happening is, like, let me give you a brief example. In the game of rock paper scissors, if you choose rock, then the program will search a database, find that for the state of rock there is appropriate state paper. It will fetch that and display that. Similarly, for tic tac toe, the complexity increases because the number of possible states also increases. In this game, there's a lot of factors affecting state generation, including the player's current X and Y coordinates, the health of enemy as well. So a lot of states will be generated. So as the complexity increases, the latency will increase. So we need to train specific models to handle that. uh, so this is for the future. And as for the business model, we think we can make reinforcement learning as a service. We can have an API just like Wabo said for individual developers. You can also make extension the SDK kits and a lot of things, so that we can sell this general training of bosses and anything reinforcement learning as a service. So this is our store. If you have any feedback regarding our idea or want to discuss anything further, we'll be very happy to have you on board. Thank you.